Okay, this video is going to go over intermolecular forces, or IMFs. IMFs are the forces between molecules. The strength of IMFs determines the state of the substance. So substances with strong IMFs tend to result in liquids and solids. Substances with weak IMFs tend to result in gases. We're going to talk about 4 different types of IMFs, and here they're listed from weakest to strongest. So the weakest is dispersion forces. Then dipole-dipole forces, hydrogen bonds, and then finally ion-dipole forces are the strongest. Let's talk about dispersion forces first. These are also called London forces, so you might see that name as well. These are present in all molecules and atoms. They're caused by fluctuations in the electron distribution within molecules or atoms. So electrons within an atom move around constantly, right? So here, at 1 second, they might be here. The next second, they're here. Next second, we're here. So if the electrons end up all on one side of that atom or molecule, that side becomes partially negative, and the other side becomes partially positive. This is called a temporary dipole. And remember, we looked at this delta negative, delta positive notation when we did the last lecture, right? When that happens, this can induce a temporary dipole in an atom or molecule next to it. So we have this atom, its electrons are all on one side, so it has a temporary dipole partially negative here. Well, when it gets close to another atom or molecule, that partially positive side will induce the next atom to have a partial negative side, partial positive side, which will cause the next one to have a temporary dipole, so on and so forth. This is a very weak attraction. And again, these are just temporary dipoles. But these are present in all molecules and atoms, no matter what. The next are dipole-dipole forces. These exist in all polar molecules. Polar molecules have permanent dipoles that interact with the permanent dipoles of neighboring molecules. So remember, dispersion forces were temporary dipoles, and these are permanent dipoles. So the positive end of one permanent dipole is attracted to the negative end of another permanent dipole in another molecule. This affects miscibility. Miscibility is the ability to mix without separating to two phases. So this means that polar liquids are miscible with other polar liquids. Nonpolar liquids are miscible with other nonpolar liquids. And this is due to these dipole-dipole forces and dispersion forces. So if we look here at acetone, here is the structure of acetone. Here's carbon, oxygen, hydrogen. This is a polar molecule. This side is partially positive and this side is partially negative because oxygen is more electronegative than carbon. So the positive end of a polar molecule is attracted to the negative end of a neighboring molecule. That means this oxygen side here of this acetone molecule is attracted to this carbon side of this acetone molecule. So positive is attracted to negative. And these are dipole-dipole forces. Next is hydrogen bonding. Hydrogen bonding is kind of a misnomer. This is not a type of chemical bond. It's an IMF. And these are kind of like super dipole-dipole forces. So same idea that they're permanent dipoles attracted to each other, but this is a special type of that. It's when polar molecules contain hydrogen atoms bonded directly to fluorine, oxygen, or nitrogen. Those molecules will exhibit this type of IMF. So here if you see in the bottom corner, hydrogen on one molecule is strongly attracted to the fluorine on its neighbor. So here we have HF, hydrogen is partially positive, fluorine is partially negative. This fluorine here that's attached to this hydrogen is attracted to this hydrogen on another HF molecule, so on and so forth. The reason these are stronger is because the electronegativity difference between hydrogen and fluorine, oxygen, and nitrogen is so great that this is a much stronger dipole than most dipoles. Here's another picture of this. So here is a methanol molecule. So this oxygen is attached to this hydrogen, partially negative, partially positive. This oxygen is attracted to the hydrogen that's bonded to the oxygen of another molecule. It will not exhibit hydrogen bonds between this oxygen and these hydrogens attached to the carbon. Remember, hydrogen bond is only between oxygen, nitrogen, and fluorine directly attached to a hydrogen. Only those oxygen, nitrogens, and fluorines and those hydrogens exhibit hydrogen bonds. Here's water. It's another example. So the hydrogens on the atoms of each water molecule are attracted to the oxygen atoms in its neighbor. You can see here. Lastly, we have ion-dipole forces. These occur in mixtures of ionic compounds and polar compounds. The positive, so for example here in sodium chloride dissolved in water, the positive sodium ions interact with the negative ends of water, and the positive the negative chlorine ions are attracted to the positive hydrogen sides of water molecules. This is called hydration. So here is a summary. So from weakest to strongest, we have dispersion forces, which are weak, but they increase with molar mass. These aren't present in all molecules. And again, these are due to a temporarily induced dipole. Then we have dipole-dipole forces, which are moderate forces. They're only between polar molecules. And it's between, these are when you have permanent dipoles. The positive side of one molecule is attracted to the negative side of another molecule. Then we have hydrogen bonds, which are strong forces. These are when molecules containing NO or F directly bonded to a hydrogen. And then finally we have ion-dipole forces. These are very strong. These are mixtures of ionic compounds and polar compounds. So these are when the ions are attracted to the polar solvent. So if you have a positive ion, it's attracted to the negative side of a polar solvent. If you have a negative ion, it's attracted to the positive side of a polar solvent.